Hello, everyone. I'm Tobias. I'm the product lead at Quantum Technologies at Zurich Instruments. And what we do here is we help build the quantum computer. And essentially, the way that we do this is by selling quantum computing control systems to research groups and quantum computing companies, and essentially as collaborators rather than suppliers, drive with them the roadmaps towards better qubits and ultimately towards quantum error correction. And our instruments, they can control readout and feedback on superconducting qubits and also spin qubits. And therefore, we position ourselves sort of just above the quantum device in the stack. And with our Lab1Q software solutions, we can then attach to the higher levels of the stack, essentially by continuously sort of continuously going up in stack and expanding, or essentially hiding the complexity of the synchronization and the complicated digital signal processing tools. And we do this to the extent that even a theoretician can now program, for example, in Qiskit, I don't know, a VQA, and then essentially execute it through the whole stack on our devices, and then ultimately controlling a QPU. And something which we firmly believe in is that this part of the stack, this needs to be as open as possible. So we supply this under the Apache license, open source. We don't charge for it because we believe really that a lot of the value is generated by essentially modifying the software, I don't know, attaching to other software solutions, integrating them into their own stack, or then co-designing part of this software together with the QPU. So we don't charge for this, but we actually make our living by selling the instruments, and we do this successfully because people believe that we know or trust us that we know what we do. And this is partially the reason why that we have been in the field for sort of the last 5 years now, and since then have sort of built up proven long-term partnerships with some of the leading companies and institutions in the world in this field. So, for example, ETH Zurich, IQM, Atlantic Quantum, Intel for spin qubits. And what they do is they really help us to design and make the right decision for the new features and new instruments. And an example here is the QHub, which is sort of a new controller which we recently launched, which can help you decode syndromes for quantum error correction codes. And the question we had to solve here was, okay, how do you build up the architecture? And do we go with a distributed system like many others do already, or do we stick with the star-like architecture? And we decided to stick with the star-like architecture because this is really something which will not impose structural or architectural limitations to research on error decoding and for the next 3 years. So what can our customers do? Well, on the one hand, they can, of course, do computing at scale up their system to larger and larger numbers. Here's a few systems that we have been supplied or plan to supply over the next years. And these customers then can do, I don't know, like ETH built the first logical qubits for superconducting qubits in the surface code configuration, or SUST recently broke even with their bosonic qubits. But we also understand very well that you cannot really drive the scaling roadmap without understanding the technology and metrology parts on the few qubit level. And this is, for example, where IBM made record short single qubit gates, or we use our lock-ins, which we also supply to lock onto microwave resonators with, in this case, a Pandora Holoc, and then do sort of look at fluctuations of this resonator and then learn something about the material. And the important thing is here that our system is modular, so you can essentially shift or cross this border at any point in time, because we invest a lot in forward compatibility, even across generations. And this brings us already to the end here. So what we generally look for? So we look for access to the labs, partnerships, collaborations with customers, both in industry and academia, because we really want to feel the pain of the researchers which are sitting in front of these machines and trying to understand and make sense of them. And because we're also a company from scientists for scientists, as we always say, we're always looking out for cool science and engineering challenges and really new chances to learn and grow together. So yeah, with this, please challenge us.